Hey y'all, let's cover lesson 6, solving one-step equations. So far we've worked with expressions. In this lesson, we're going to expanding our scope to equations. So let's give you a couple definitions of things that's going to help understand the difference between expressions, equations, and what a variable is. All right, so a variable is just a symbol. Don't get all caught up in the fact that you're thinking of it as a letter. It's not, it's just a simple symbol. Usually a letter is a symbol, usually a letter. And it stands for a value. So it stands for a value that may change or that may vary. That stands for a value or a number that may change, that may vary or change. All right. So up till now, we've only seen expressions. At this point, we're going to start using equations, and equations has a mathematical statement. So it's not just 3 plus 4 or 3x plus 1. There has to be an equal sign, hence the equa. Equa is for the equal sign. It's a mathematical statement. So it's a math statement that puts an equal sign, That's the big thing, the equal sign between two expressions, The most important part that you need to get from this is the equal sign. So for an equation, there needs to be an equal sign in order for it to be an equation. The following are considered expressions. So this is an expression. There's no equal sign. This is an expression. There's no equal sign. And this is an expression. Again, no equal signs. All right, so while these are equations, so we've got this one to where it's the same concept, but now they have equals to another expression or a number. Same thing here, 3x plus 3 is equal to 4, and 3x is equal to 9. There's an equal sign, so therefore it's an equation, not an expression. A solution of an equation is a numeric value. It's a numeric value, the number, numeric value that satisfies the equation. That satisfies the equation. Okay, when a variable is repeated, when a variable is replaced by the solution, a true statement results. So when you substitute the variable for the solution, what happens is true, and I'll show you what that means. So when the variable, gosh, I keep saying that, when the variable is replaced by the solution, a true statement results. All right. All right, here's an example of this. Show that 3 is a solution of the equation x plus 8 is equal to 11. So I'm just going to rewrite it. X plus 8 is equal to 11. I write down the equation. First thing I do. And then I substitute 3. So I replace x with the value. So 3 plus 8 equals to 11. And now I simplify both sides to make sure it's complete. Simplify So each side is one number. So each side is one number. That's 11 equals 11. Okay, did that. And then if that's the case, if the 11 equals an 11, then that says that yes, 3 is a solution of this equation. So yes, yay, it's true. It's true, it's true. You have to decide if it's true or false. Decide if true, ours was, or false. Okay, so the answer is yes, 3 is a solution. All right. Is 8 a solution of 5 equals 12 minus y? Well, we have another equation, and we're going to see if 8 is a solution. So we're going to write the equation. 5 is equal to 12 minus y. Now we're going to replace x with the value. Now it's going to be y. So replace the variable with the value. 5 equals 12 minus, and they're looking for 8. And now we need to set them, we need to simplify. So each side is one number. Well, this one's already one number. 12 minus 8 is 4. All right, did that. And then decide if true or false. Well, 5 does not equal 4, so this is false. And your answer is going to be no, 8 is not a solution. Is not a solution. All right. Two equations are equivalent if they have the same solution set. If they have the same solution set. We'll discuss that. All right. Are the equations x plus 2 equal 9 and x equals 7 equivalent? Well, I can take and go, okay, x plus 2 is equal to 9. Well, what numbers can I plug in for x? There's only one number I can plug in for x. 7 is the only solution. Because 7 plus 2 is equal to 9. 9 equals 9. So 7 is the only solution for this one. So sorry. Too many lectures in one day. 7 is the solution, the only solution. All right. What about the other one? X is equal to 7. Well, again, 7 is the only solution. Only solution. All right. So yes, they are equivalent. They are equivalent. Okay. Next page. All right. Example, are the equations x equals 4 and x plus 8 equal 3 equivalent? Well, let's start with x equals 4. 4 is the only solution. 4 is the only solution. All right. Now x plus 8 equals 3. What number? I'm sorry. It's totally opposite. X plus 3 is equal to 8. There's only one number we can plug in for x that we can add to 3 and get 8, and that is 5. So 5 plus 3 equals 8. 8 equals 8. So 5 is the only solution. All right. So no, they're not equivalent. because 4 is the only solution for this one, and 5 is the only solution for this one. So no, not equivalent. All right, notice that it's easier to determine the solutions for x equals 4 than it is for x plus 8 equals 3. Oh, it is written wrong here. That's what I was looking at. Oh, it's written wrong here too. Oh, that's why my issue is. I was writing it incorrectly. It should be x plus 3 is equal to 8. That's crazy that it printed off this way. I don't know. All right, so x plus 3 equals to a. Our goal in solving equations is to produce an equivalent equation that is less complicated than what we started with, but in particular, we're trying to get an equivalent equation that looks like x equals 4 or x equals 7. So what's special about these? One side only has a letter or a variable. One side only has a variable, the letter, and one side only has a number. Only has a number. All right. There are many operations that will produce equivalent equations. Adding the same quantity to both sides of an equation does not change the solution set. So if A is equal to B, then you can add C to both sides. Adding C to both sides produces an equivalent equation. Produces an equivalent equation. So A plus C, well, let's do it this way. If A equals B, so if A equals B, then I can add C to A. But what I do to one side, and you're going to hear me say this a whole bunch this semester, what you do to one side, you have to do to the other, because there's this cute little thing called an equal sign. And so you've got to keep both sides equal. And if A and B are already equal, then you add C to the other side, then now they're not equal until you add C to the opposite side. Okay, you've got to keep everything equal. Otherwise, the equal sign has no meaning. Again, this is just a language. All right, consider x minus 4 is equal to 3. All right, so what is its solution? How can we apply this property? Well, if we've got x minus 4 is equal to 3, I always rewrite the equation just to give myself a basis to work from. And then I looked, my big question I asked myself is, who is attached to the variable and how? So the question I ask myself here is, who is attached, or what is attached? I call it who is attached to x and how? So the 4 is attached to x with subtraction. Okay. In order to get x isolated all by its little lonesome on one side, we have to get that negative 4 or that subtracted 4 away from the x. The only way to get rid of a 4 that's subtracted is to add 4. And when you do that, 4 minus 4 is 0. So that leaves me with just x on my left side plus 0. But I can't just add 4 to the left side of the equal sign. Because there's an equal sign, I have to add 4 to the other side. You just can't make it go away on one side. You have to keep it equal. So 3 plus 4 is 7. This equal sign comes down here as well. So this becomes x, because x plus 0 is x, is equal to 7. And that is it. 7 is our solution. And that's how we apply the property. All right, the next one is subtracting the same quantity from both sides of an equation does not change the solution set. It's the same concept as the addition version. That is, if A is equal to B, then I am subtracting a C from both sides. Subtracting C from both sides produces an equivalent equation. Produces an equivalent equation. Okay, so what that means is I'm going to take that A and I'm going to subtract C, but we have an equal sign again. And so if A and B is equal and we subtract C from A, we've got to subtract C from B. All right. Consider x plus 4 is equal to 9. What is its solution? How can we apply this property? So again, I'm just going to rewrite my equation. And again, I'm asking myself, who is attached to x and how? So 4 is attached to x by addition. In order to get rid of it, you have to do the opposite of addition, which is subtraction. So I have to subtract 4, but when I subtract 4 from one side, I have to do the same thing to the other, because otherwise it wouldn't be equal. So this becomes x. I'm not going to put plus 0 again because it's kind of obsolete and it wastes your time. I'm going to bring my equal sign down, and then 9 minus 4 is 5. So x is equal to 5 is the solution. Okay. Please make sure as you're taking notes, you write down any questions you have so that you can ask in class or shoot me an email or whatever the case may be. All right, showing your work. So many times students ask me, God, how much work do I need to show? Do I need to show all of my work? Do I need to show every single step? And there's a couple of things that I ask. Do you want partial credit? That usually is the big one, because if you just take a question and you just give me an answer with showing no work, there's no partial credit. It's either right or wrong. But if you show your work and I see where you maybe messed up a little bit, maybe you added something wrong or you multiplied something wrong, and that's only a piece of the problem, then I can give you partial credit for the stuff that you did right and only take off a few points as opposed to all of it. The other thing is, if you don't write your steps down, you're going to be more apt to make mistakes, because then you're not being able to follow, I need to be able to follow your logic to make sure you understand what you're doing, but you need to be able to follow your logic to make sure that you're not missing a negative symbol, or make sure you're adding properly. Skipping steps does not benefit you. It doesn't benefit you in any stretch of the imagination. There's just more opportunity to get things wrong. So please show your work. If I have to show work, and I show way too much here for some people, but I still have to, if I have to show the work, you definitely have to show the work. All right, so one equation per line when showing your work. One equation per line. Got to keep it neat. So when you have x plus 3 equals 7, x plus 3 minus 3 equals 7 minus 3, x equals 4. Don't do this. Do not do this. This is a no. Do not do this. Okay. It's too hard to follow for me. So if it's too hard to follow for me, there's more apt of a chance of you getting it wrong. So here's how you do it. This is the way to do it. X plus 3 equals 7. Subtract 3 from both sides. X equals 4. Square or circle your answer. That's always nice. Professors love that. All right, number 2 is add or subtract inline or vertically, which is what I did. Add or subtract inline or vertically. So if you have x plus 3 is equal to 7, if you do x plus 3 minus 3 is equal to 7 minus 3, then x equals 4. You can do that. That's in line. Vertically is the original one, which is just the x plus 3 equals 7. and subtracting 3 from both sides, and x equals 4. So, just to show you how to represent your work. All right. Suppose you're wrapping a gift for your cousin, and you perform the following steps in order. You put the gift paper on, you put the tape on, you put the decorative bow on. When the present the wrapped gift for your cousin, she politely unwraps the present, undoing each of the steps in the opposite order. So she takes off the bow. She takes the tape off. And she takes the paper off. There's a reason for this. Why are we talking about this? So consider the expression x plus 4. To evaluate this expression for some particular value of x, it's an expression because there's no equal sign. We would start with that given value of x, then added 4. Okay. If, for example, we started with the value of 7, we would apply the first step and get the result. How could we unwrap this result to end up back at our original value? We would start with the result, and then we would subtract 4. And then this leads us to some important conclusions. The inverse of addition is subtraction. I always like to say the opposite too, if it helps you think of it differently. If we start with a number x, just any number, and add a quantity a, then subtract a from that number, we're going to get the original number. All right. If we have x, we add a, and then we subtract a, we're going to get x, is what they're saying. All right. So the inverse of subtraction is addition. I'm going to write this one differently. So x, subtract a quantity a, then add a quantity a, we're just going to get x, because inverse of subtraction is addition. Okay. All right. We're going to solve some equations for x. All right. We've got solve x plus 5 is equal to 12. So x plus 5 is equal to 12. Again, I always rewrite the equation, and then I start my work. Who's attached to x and how? Again, I'm going to keep using that. Who's attached to x and how? 5 is attached to x with addition. We know the inverse for addition is subtraction. So, or the opposite of addition is subtraction. So to get that 5 away from that x, we have to subtract 5 away from it. All right. But what we do to one side, again, the equal sign, we have to do to the other. So the left side becomes x, and the right side becomes 7. Circle my answer, and I'm done. I can check this. Let's check just to make sure. That means I should be able to plug 7 in for x plus 5, and it should equal 12. 7, 8, 9, 10, 11, 12 equal to 12. It checks out. So x equals 7 is correct. It's a good idea to get comfortable in checking your answers just to cover yourself, just to be safe. So let's solve 11 equal y minus 8. Okay, who's attached to y and how? 8 is attached to y by subtraction. The inverse of subtraction is addition. The opposite of subtraction is addition. So to get rid of this 8, we have to add 8 to this side. All right, but what we do to one side, we have to do to the other because there's an equal sign. I'm going to bring that down. 11 plus 8 is 19, and then the right side just becomes y. To check that, I'm going to take my original, the 11 is equal to, where the y is, we're going to say that that's 19 now, minus 8. So the right side is 11, it checks out, so y equals 19 is our solution for that. All right, the next piece, application word problems. I know everyone freaks out when they hear word problems or fractions. Let's work through this. We're going to be doing word problems in every single one of these sections because once you get to problem solving, your Math 1500, the majority of the class is word problems. So you're going to set up a variable dictionary. So we're going to label what things are. Set up, these are your tools of how to handle word problems in this class and going forward. Set up a variable dictionary. It's like a map to help you understand how to solve the problem. You need to let your reader know what each variable represents. So you need to know, you need to let your reader, which would be me, know what each variable represents. Okay. Here's what you can do. You can use a statement like, let P represent the perimeter. You can use a statement like, let P represent the perimeter. Label unknown values. Label unknown values with variables in a table. With variables in a table. And then another one is to label unknown values in a sketch or a diagram. Label unknown values in a sketch or diagram. Okay. All right. Number 2 is you're going to set up an equation. Set up an equation. You're going to use the variable or variables to write an equation. Use the variable to write an equation. The ones that you've, your variable dictionary, you're going to use those to write your equation that models what the problem is, that models the problem. All right, number 3 is you're going to solve the equation. And then number 4 is you're going to answer the question. There's always a question about something they're going to use the equation for to find something out. So 4 is you're going to answer the question. They don't ask for just an equation. Answer the question. Your solution should be written. Your solution should be written. And I mentioned this earlier. In sentence form. In sentence form. With appropriate units. With appropriate units. The other thing I say is rounding, and rounding. Just to make sure. And then number 5 is look back. Does the answer make sense? So does your answer make sense based on the words of the problem? So if I ask you to tell me what the price of gas was in 2024 or 2022, and your answer comes out, and you literally write this, because I've had people write something that's crazy. The price of gas was $635.42 per gallon. Or if I ask for the price of a house or the price of a car. So my 2023 Silverado, what is it? My Subaru. Somebody, whenever they answer the question in sentence form, they said the Subaru cost or was worth $648 million. Let's look back and make sure that the sentence that you're writing is answering the question and is appropriate. All right, so look back. Look back. Does your answer make sense? Does your answer make sense? Don't just write any old number down. You've got to make sure that it's legit, based on the words in the problem. Based on the words in the problem. All right. For more than a certain number is 12. Find the number. So let's give some information here. We need to create a dictionary, a variable dictionary. We're going to let X be the unknown number. Be the unknown number. All right. So then for more than, if you have the words more than, they're throwing a really tough one at you right now. We shouldn't have done this. More than means you're going to flip. So for more than a certain number. So a certain number plus 4 is 12. Is always means equals 12. This number plus 4 is 12. You could have written 4 plus X is 12 as well. So now we need to solve for this unknown number. Who's attached to X and how? So 4 is attached to X by addition. The inverse, or the opposite of positive 4, is going to be subtracting the 4. What you do to one side, we have to do to the other because of this equal sign. This gives us X, bring the equal sign down, and 8. All right, so that is not what we're doing, because we have to answer the question, and your solution should be written in sentence form. Mine is not. And I have no units. There's no units for this one, but to write it in sentence form, I'm going to write the number is 8. That is the correct way to do it, right? Going on to adding here. All right. Emily, I don't know. Withdraws $125 from her savings account. All right. Because of the withdrawal, the current balance in her account is now $1,200. What was the original balance in the account before the withdrawal? Well, we're going to let X be the original balance. This is my dictionary. Be the original balance. All right. And when we do that, what we're doing is we're going to have to take that original balance. I'm just going to write out what we're doing just to help us see what's happening here. The original balance minus the withdrawal. This is going to help me design my equation. Equals the new balance, not the sneaker. All right. So our original balance we're labeling as X. So this, I'm going to substitute and put X in. Minus the withdrawal. Well, the withdrawal was $125. Right? Equals, I'm bringing my signs down, my new balance, the current balance is now $1,200. Okay, I'm going to solve for X. So I have to look to see who's attached to X and how. 125 is subtracted from X. So we're going to do the inverse of subtraction, or the opposite, and we're going to add 125 to both sides. Do to one side, to do to the other. That leaves us with x is equal to 1,325. Answer it in sentence form. The original balance was $1,325. All right, that is my answer. All right. The perimeter of a triangle is 114 feet. I need to take a pause for just a moment. I'll be right back. Okay, sorry about that. The perimeter of a triangle is 114 feet. Two of the sides of the triangle measure 30 feet and 40 feet respectively. Find the measure of the third side of the triangle. I need a picture. You need to know what's going on here. So we have a triangle, and it says the perimeter of the triangle is 114 feet. So that means you add up all the sides. Side 1 plus side 2 plus side 3 is going to equal the perimeter. Remember, it's adding up all the way around the shape. So two of the sides of the triangle measure 30 feet and 40 feet. So we'll say 30 and 40, and these are feet. Find the measure of the third side of the triangle. So we're going to let x equal the third side of the triangle. So x. I'm going to let x equal the third side. All right. So side 1 we'll call x, side 2 30, and side 3 40. And they all add up to the perimeter, which is 114, because the perimeter is equal to 114 feet. So 114. All right. Working through the left side, we're going to combine like terms or simplify. So this just becomes x plus 30 plus 40 is 70. And that's equal to 114. Now I need to isolate x all by its lonesome. I'm going 70 is attached to x with the addition. So we're going to do the opposite or the inverse of addition, which is subtraction. We're going to subtract 70 from both sides. And we get x is equal to 44. All right. Finally, write this in sentence format. The third side is 44. Don't forget the units, feet. All right. To help you write your sentence, literally use what you labeled for that x. Third side, the third side is, and just keep it very simple for you. It's also provided up here. The third side is, or the third side of the triangle is. Go with what they're asking you. All right. Okay, multiplying both sides of an equation by the same quantity does not change the solution set. That is, if A is equal to B, then A times C equals B times C. It does not change the solution set. Dividing both sides of an equation by the same quantity does not change the solution set. That is, if A is equal to B, then A divided by C is equal to B divided by C. Another way to write this, to think of it, because we don't usually write like this for our divisions. So to help you see it a little bit better, it's A over C is equal to B over C. You can divide both sides by the same number and it's still equal. Okay, once you do to one side, you have to do to the other. In this case, C cannot be 0 because we've discussed that that is undefined. All right, the inverse of multiplication is division. If we start with a number x and multiply by a number a, then dividing the results by that same number a returns us to the original number. So if we have x and we multiply times a, and then we come along and we divide it by a, this is equal to x times 1, or a over a, and anything divided by itself is 1. So x times 1 is x, just to represent what's happening there. The inverse of division is multiplication. All right. If we start with the number x and divide it by a number a, then we multiply it. So it's the opposite of what we just did here by a. That returns us to our original number x. All right, let's do a couple of these so you can get comfortable with this. So solve the equation 3x is equal to 24. So we're going to solve for x. What you need to understand is anytime there's a number smack dab up against a variable, then this means 3x means 3 times x, so that you can understand that. So we've got the problem itself, the equation, and we're solving for x. I'm going to ask myself the same question. Who's attached to x and how? 3 is attached to x because we want x by itself by multiplication. The inverse, or the opposite of multiplication, is division. So to get rid of that 3, we're going to divide both sides by 3. 3 divided by 3 is 1. So now that's x is equal to, and then what's 24 divided by 3? And that is 8. Okay, so x is equal to 8. Let's check our answers here. We've got 3 times 8 is equal to 24. This is our check. 3 times 8 is 24. 24 equal to 24. Golden. It works out fabulous. Now let's solve x over 7. X divided by 7 is equal to 12. Who's attached to x and how? 7 is attached to x by division. The opposite of division, or the inverse of division, is multiplication. So I'm going to multiply this side by 7. What you do to one side, you have to do to the other. All right, well, this becomes, when you multiply fractions, 7 over 1 becomes 7x over 7 is equal to 12 times 7 is 84. 7 divided by 7 is 1. So this just becomes x is equal to 84. All right, to check, we're going to put in 84 divided by 7 equals 12. When you divide 84 divided by 7, and that is 12, equals 12, we're golden. Okay, so that works perfectly. This is something that really confuses folks. I kind of want to go over this one more time. So when you have a fraction equal to a number, to get rid of that denominator, you need to understand that you're dividing. So we have to multiply by that same denominator. So we're going to multiply both sides by that 7. When you do that, we're able to reduce these to 1 because 7 over 7 is 1. And then 12 times 7 is 84. This is the side I don't want to lose you on. Okay, if you have trouble with this, please reach out to me and let me help. 15 times a certain number is 45. Find the unknown number. Well, we need to label here. So we're going to let x equal our unknown number. All right. And now we can write 15 times a certain number is 45. All right. So this is 15x equals 45. Who's attached to x and how? Let's solve for x. 15 is by multiplication. Opposite of multiplication, or the inverse, is division. So we're going to divide both sides by 15 to keep everything equal. 15 divided by 15 is 1. So that's just x is equal to 3. So that's not my answer. It is a sentence word problem. So the unknown number, or certain number, however you want to call it, number is 3. And that's the answer. Okay. The area of a rectangle is 120 square feet. I need to write down what's going on here. Let's start by drawing my rectangle because I know I'm going to need one. All right, and the area is 120 square feet. I'm gonna put feet squared. The length of the rectangle is 12. All right, so 12 feet. Find the width of the rectangle. So the width, we'll label it W. Okay, because it's width. And they want us to find the width. Well, we need to understand with a rectangle that this side equals this side. Oh, it's area. So area for a rectangle, is equal to length times width. A equals LW. So the area we know is 120. The length they're told us it's 12, and we're looking for width. And I'm going to let W represent width, just to give us our definition of what W is. Who's attached to W and how? 12 is attached by multiplication. The inverse of multiplication is division. So we have to divide both sides by 12. And when you do that, 12 divided by 12 is 1. So you're left with W equals 10. 120 divided by 12 is 10. So to finalize the answer, the width is 10 and then units feet. Last one for this lesson. A class of 23 students averaged 76 points on an exam. All right. How many total points were accumulated by the class as a whole? So the average is equal to the total divided by how many? How many, in this case, is 23 students. All right. The average is 76. So the total is going to equal X. We have to label our definition. All right. So we've got average, which is 76, is equal to the total divided by how many? Okay. Who's attached to X and how? 23 is attached by division. The inverse of division is multiplication. So we have to multiply both sides by 23. Okay. Just another way to represent multiplication. I actually double dutied it here. 23 times 76 is 1,748. 23 divided by 23, because these are going to reduce and give us 1, is equal to X. So how many total points were accumulated by the class as a whole? The total points for the whole class was 1,748. All right. Let me know what questions you have and have a great day. See y'all next time.